Shit. Good evening, Vishal, Kanishka, Rahul, Sharmila, Krisha. Sharmila, Krisha, Maranisha, Kanishka. Good evening. Hi, ma'am. I'm Darshini. Okay, Darshini. I know Darshini. Just 1 minute, huh? Just 1 minute. Just give me 1 minute. I'll start. Fine. So now what is the question? First question for you is, so we are going to start revision for structure of atoms. In structure of atoms, what we are going to do is, we will be discussing about, just 1 minute. This pop-up is creating problem for me. Fine. So now what we have to do here is, our first question is that that one ABCD answer I don't want, because now MCQ questions will not be coming. You will be getting what type of questions? You will be getting questions 2 marks, 3 marks, 4 marks questions. So based on that only we are going to just practice. Give an important characteristics of canal ray. So we have discussed about canal ray. Can you tell me what is the qualities of canal rays? Because we have discussed two. One was cathode rays, second was canal rays. So what is the difference between cathode rays and canal rays? Cathode rays and canal rays. Hi Ekta. Cathode rays and canal rays. What is the difference between cathode rays and canal rays? Because we have already discussed about cathode and canal. So just answer the questions. Start answering the questions quickly. Canal rays are, what are the characteristics of canal rays? If somebody will be telling you canal rays are positively charged, absolutely correct. Canal rays, Karishka, canal rays are absolutely charged. Cathode rays are negatively charged. Anything else you want to say? Anything else? Because at the time of learning we have done much of experiment and we have discussed about if canal rays are positively charged, then what they are exactly called as and what are the properties it is exactly having. Come on, quickly tell me. You can say that. Fine. Come on, say me fast. What are the exactly answers for cathode rays? Just think about it and say. Think about it and say. You can say that. So they are positively charged. Okay, Kanishka has given the answer. Canal rays travel along a straight path in absence of electric and magnetic field. Canal rays are positively charged radiations. Madhav, canal rays. Canal rays, yes, very good. It is exactly coming from anode. Absolutely correct, Madhav. Next is canal rays are positively charged radiations due to positive charge. They move in straight line. Correct, Madhav. That is the second point. They move in straight line. Next, due to positively charged subatomic particles. So that's why now we have given canal rays as positive charge name, and that is proton. And cathode rays as negatively charged particles, and they are exactly negatively charged subatomic particles, and we have given they depend upon nature of the gas kept in the tube. Absolute, Madhav. Madhav, is this your name, Madhav itself? So canal ray, they are discovered by Goldstein. Back to back you have given all best answers. Super, Madhav. So exactly the answer is absolutely correct. I think it's Keshav, huh? Keshav, you have changed your name to Madhav. Come on, it's time to reveal yourself. Madhav is exactly Keshav or Madhav is different? Good evening, Rajesh. Come on, tell me first. Madhav, that was awesome. Super. Nice answers. Now look here. Next is name the particles which determine the mass of an atom. Which determine the mass of an atom. I've showed you the answer also. Super. Super. Very good, Keshav. afterwards. So exactly, Madhav is different and Keshav is different. Fine. Okay, fine. I understood. Fine, Keshav. Shall we start? Next question, please. Now look here. Name the particle which determine the mass of an atom. So we understand one thing. First, let me wear my. What you say in this? Proton and neutron, absolutely correct. Proton and neutron exactly determines. Keshav, what is your score? Tell me. Proton and neutron are exactly present in the nucleus and it determines the mass. Madhav, neutron or nucleus? Absolutely correct, Madhav. So proton and neutron is the correct answer. Shall we go for the next question? Write the charge and mass of an electron. This is exactly going to be the best question, because I really want you to tell the answer. What will be the charge and mass? Charge and mass. Come on, you can answer the question. Charge and mass of electron. Charge and mass of electron. You already know what is the charge and mass of electron. You just have to think about it and you will be getting the correct answer. Charge and mass of electron. Charge and mass of electron. 1.6 into 10 to the power minus 19 coulomb is the charge. That is exactly the charge. But Madhav, electron is also one more important thing which you should add here, and that is electrons are negatively charged. Electrons are negatively charged, and the charge of electron is 1.6 into 10 to the power minus 19 coulomb. What will be the mass? 9.1. I don't know about the mass. Tell me, what is the mass of electron? Charge and mass of electron. So no comparison, just you can say that what is the mass of electron. Mass of electron is Keshav, my friend, ma'am. Okay, Madhav is your friend, but he is very good. Nice answer he is giving. Now here do thank you, CB. Thank you so much. God bless you. Shall we go back to our work? Electron, lightest stable substance particle known. It carries a negatively charged. Yes, but I'm very much keen to know what is the mass of electron. Can you tell me what is the mass of electron? Because after knowing the mass of the electron only, I'll be coming to know that you have given the correct answer. Because charge of electron, Madhav, 9.1 into 10 to the power minus 31 kg. Now it is the absolute answer. Yes, Sharmila, 9.1 into 10 to the power minus 31 kg is exactly the mass of electron. Absolutely correct. Thank you, CB. God bless you. Now Rahul, 9.1 into 10 to the power minus 31. Answer is absolutely correct. Yes, Avinash, 9.1 into 10 to the power minus 31 is absolutely correct answer. Super. So we'll go for the next one. We'll go for the next question. They have assertion region questions. I don't need these questions. So we will be going back to the next question. When gold foil, now read out this question. This is a long question. When a gold foil is bombarded by a beam of particle, only few of them get deflected, whereas must go straight undeflected. Most of them go straight undeflected. This is because of what is the reason behind that most of the rays goes undeflected? If somebody will be asking from you, what answer you are exactly going to give? So what is the reason behind most of the rays goes undeflected? Bombarded means attacking. You know that zinc part was there, and we have seen this part that most of the rays were what was the Kanishka, we have discussed this. Bombarded means attacking the gold foil, and helium particles, that is helium was exactly, that is alpha particle. I told you doubly charged helium atoms, alpha particles were doubly charged helium atoms, and they exactly bombarded on gold foil. What happened to you, Kanishka? Final time revision. Because large space in atoms, Vishale, supernova answers. Super here, back to back. Who is this Madhav here? Creating havoc here. Nice answers. Okay, Kanishka, Vishal, because the mass of nucleus is concentrated in small volume. Absolute. Okay, Lokesh, hi ma'am, after long time. Lokesh, that now examination time is coming. Now I want everyone come in offline class also. Now next, Avinash, I think it's scattered. It has enough space, ma'am. Yes, it is exactly, lots of empty space is there, and the nucleus is concentrated into a very small region. because of that only, whatever rays were there, we exactly expected that atom is, most of the atom part is empty. So what happens that when doubly charged helium atoms or the positive charges are going there, then what is happening that they went undeflected, they are going undeflected and they are returning. Most of them are going undeflected. Some of them, those who went very near to the nucleus, they made some angles and they came out, okay. But the one who strike the nucleus, they only exactly retraces its path, that is exactly coming very returning back. So that is the most important point. I hope you might have understood this one. We have already had a long discussion related to it. So Ashwin, when the alpha particles, yes, the nucleus, the repulsion occur on particles, deflection, and most of the rays passes because it has mass. Okay, 180 degrees. Rutherford alpha particle experiment, Avinash, absolutely correct, that one. So Rutherford alpha particle experiment, in that only we have understood this point, that most of the rays goes undeflected. Undeflected means we have to just understand this point of view, that he has taken a zinc sulfide plane, and in that you might have seen that gold foil was there, and then from a small chamber he allowed the rays to go here. So what happened, his expectation was all the rays will go here, but beyond his expectation, some of the rays went and striked, and very few of them retraces its path, very few of them went and returned back. Okay, so this was his expectation. This is exactly called as expectation versus reality. So here expectation was, it is exactly all the rays will go straight without undeflected, but exactly reality was some of the rays made some angles. Okay, some of the rays, it is exactly after coming it made some angles and it strike back like this. I just drew it wrong. So it is exactly made some angles and strike back like this, and it is exactly captured in the zinc sulfide screen. So that was exactly yeah, it was consisting of 1000 atoms, gold atoms, 1000 gold atoms. It was exactly expected. So some of them exactly deflected back by making some angles, and very few of them retraced its path. Retraced its path means going and returning back to the same path, and exactly this happened. And this experiment let us to understand that definitely atom is exactly not empty. Atom is having nucleus, and it is a very small region the nucleus is present. And second important point is the reason where nucleus is present is concentrated and it is positively charged. Okay, so positive charge, like Jj Thomson experiment, it was not scattered everywhere. Like Jj Thomson experiment, the most important point he revealed that okay, fine, all the positive charges and negative charges are exactly present in the same figure. Watermelon experiment he has given, and that was exactly not the fact. The fact is that when the ray was exactly going, most of the rays got undeflected, but some of the rays exactly got trapped in the zinc sulfide screen, explaining one very important point, that there is something inside the atom which is exactly reflecting them back by making certain angles. Okay, reflecting them back, and then he fall into his observations and conclusions. I hope you might have understood this point. Come on, quickly say you have understood this point, then we'll go for the next point. Yes, then we'll go for the next point. Absolutely correct, Ashwin. Nice experience. Wow, super, Ashwin. So, shall we go back to our work, please? Shall we go back to next question? Where are the girls today? All are very, very silent. So I'm not going for MCQ questions. I'm just going for answers. Which of the following statement does not belongs to this answer? We don't need. Which of the following are positively charged? Come on, see this one and tell which of the following are positively charged. Which of the following are positively charged ions? By seeing itself, you have to say that which of the following are positively charged ions. By seeing the A, B, C, D, E, F, you have enough time. Just see the picture and just explain that which of them are positively charged ions. Which of them are positively charged ions? Lokesh is telling answer C. Tough competition, dear. Tough competition. first thing is that we know that for an atom, the number of electron will be equal to the number of proton. This is the first part of the answer. The number of electron will be equal to the number of proton. So this is exactly the first part. So now just look here. Just don't go more anywhere. Don't use more of the concept. Just use some simple part of the concept. The concept says that for an atom, number of electron will be equal to number of proton. So here number of electron is 17, number of proton and electron is 17. So it's just an atom, it's not at all an ion. Fine. Now here you see number of proton is 12 and number of electron is 10. That is 2 less than number of proton. That means inside nucleus 12 protons are there, outside only 10 electrons are there. That means 100% this electron has donated 2 electrons to someone. Okay, so this electron has given 2 electrons to someone. So okay, no problem Lokesh, no problem beta. This is what I am very happy Lokesh, you are answering today. Fine, let's see who and all are answering nicely. So proton is positive, electron is negative, absolutely correct. And next is, you have to understand one very important point here is that positive charges. So look here, so electron number and proton number are not same here. Electron here, 2 numbers of electrons are less. So since 2 number of electrons are less, so 100% it is exactly an ion. Okay, it is an ion and it is a positive ion. It is a positive ion because here electron number is less than proton number. So since electron number is less than proton number, that means electron has been coming out. Electron has been coming out. For your understanding, I am going to draw and explain why it is exactly going to be called as positive ion. Now let's have a look. Now look here. So when proton number is 12, electron number is 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is supposed to have 12 because inside proton is there. So now it is not having 12, it is exactly having 2 less. So since it is exactly having 2 less, so it is exactly containing 10 number of electrons. So since it is exactly containing 10 number of electrons, 1, 2, 3, 4, 5, 6, 7, 8, and then 2 extra orbit I am going to shift it up. Okay, so I am going to shift it to third orbit, 1, 2, 3 and 4. It has supposed to be here 4, but exactly it is missing 2. So since it is exactly missing 2, so that means it is what? It is a positive ion. It has to be it has to be 12, but it is having 10, means it has donated 2. So since it has donated 2, means it is a positive ion. Fine, it is what? It is a positive ion. So now we'll go back to the next part. Here that means B is our answer. Now see, you see here 16 and 17 is there. Can anybody tell me this is exactly going to be an ion? It is exactly going to be a positive ion or negative ion? It is exactly going to be a positive ion or negative ion? Come on, you can answer this one. C answer. I'm just waiting for C. I want you to say the answer for C. Is it going to be a positive ion or a negative ion? Is it going to be a positive or a negative ion? Is it going to be a positive ion or negative ion? Absolute. So they have asked in the question, yes, absolutely correct. They have asked in the question positive ion. They have asked what? They have asked about positive ion. So this is not our answer. 100%. This is not at all our answer. So we are going to cut this one. We are going to cut this one. Now you see, proton number is 1 and electron number is 0. So number of proton is 1 and number of electron is 0. That means what answer we are expecting? What answer we are expecting? The answer is exactly, it is going to be a positive ion. So your correct answer is B and D. Your correct answer is B and D. Super answers. Very good. Where that boy went? So next, electron number and proton number is same. So that means it is not at all ion. Now here proton number and electron number same. So again it is not at all ion. Okay Prashant. Okay Prashant. Thank you so much beta. I'll start. From tomorrow onwards we will start live classes. What is proton and who discovered it? 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 So I just showed the answer also, no problem. But I was shuffling it, so answer came out. So what is proton and who discovered it? Come on. Proton answer you can give nicely. What is proton and who discovered it? 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 Proton is positively charged particle discovered by Goldstein. Back to back, yaar, super answer. Very good. Keshav, he is a nice competitor for you. Now what is proton? Proton is positively charged and it is ekta. Proton is positively charged particle. It was discovered by Goldstein. Absolutely correct. It is a positively charged particle discovered by Goldstein. Now give the next answer. If an atom contains one electron and one proton, will it carry any charge or not? That's the very good question. Now come on, answer this question. This question I want everyone to answer. Where is Shrutika, Sharmila? Everyone is sleeping or what? I want a full attendance here with answers. Come on. Okay, Keshav has given the answer no. Lokesh, correct answer. Keshav, no. Ekta has given answer no. Ashwin, electrically neutral, ma'am. Okay, Ashwin has given the answer that if number of proton is equal to, okay, Vishal has given answer no, electrically neutral. Vishal is stick to its point that it is electrically neutral. Ashwin is also stick to its point that it is electrically neutral. Come on, let's have a look. So what is exactly, if an atom contains one electron and one proton, will it carry any charge or not? So 100% when number of positive charge is equal to number of negative charge, so one electron, so it is exactly, it will not carry any charge because it will be electrically neutral. The answer what you have given is absolutely awesome and super. So now we will, who discovered neutron? Now come on, let's see who can give this answer as fast as possible. Who discovered neutron? Who discovered neutron? No, because it is neutral. Absolutely correct. Now who discovered neutron? I am just covering the screen, just I am moving. Who discovered neutron? I am just wanting to know the answer. We have already done Keshav. James Cavendish, Vishal Chadwick, Rahul Chadwick, Kanishka James, Ashwin Chadwick, Sharmila James Chadwick, Vishal in the year 1932. What a precise information, Vishal, bang on air. 1932 is absolutely correct. James Chadwick, Avinash. Super, the answer is absolutely correct. Exactly, neutron was discovered by James Chadwick. It was exactly discovered by whom? James Chadwick. Answer is bang on correct. So James Chadwick. Now James Chadwick discovered a subatomic particle which has no charge and has mass nearly equal to that of proton. Name the particle and give its location in the atom. Share. They are asking this question and I think you are going to kill this question in no time. Come on, you can answer this question. I know my children. I trust you all. So come on, give the answer. Give the answer in the best possible way. Chadwick discovered a subatomic particle which has no charge and has mass nearly equal to that of proton. Name the particle and give its location in the atom. Madhav, absolute fabulous answer, Madhav. So exactly, neutron, answer first. Ekta has given Madhav. Neutron and nucleus. Keshav, neutron, nucleus. Ashwin, neutron, inside nucleus. Okay, Kanishka, neutron, nucleus. Fine. Rahul, neutron. Absolute. Ashwin, nucleus. Monish, nucleus. Avinash, neutron and nucleus. Fine. The answer is absolutely correct. Absolutely correct. Correct. So that is the answer is what? Answer is nucleus and neutron. So Chadwick discovered a subatomic particle which has no charge and has mass nearly equal to that of proton. So since it is having no charge, it is exactly, name the particle. The name of the particle is neutron. Where it is present? It is present in nucleus. Now an uncharged particle is found in the nucleus of an atom. Identify this uncharged particle. So you will just say that right now only we have said it's neutron. So no need to ask about it. Fine. So we will go for list 3 subatomic particles of an atom. What are the 3 subatomic particles of an atom? Or write the names of 3 elementary particles which constitute an atom. See, they will ask this question. Lokesh, bang on performance here. You came with a very bang on performance. Super. So now everyone tell this answer. Write the names of 3 elementary particles which constitute an atom. Write the names of 3 elementary particles which constitute an atom. Write the names of 3 elementary particles which constitute an atom. names of 3 elementary particles which constitute an atom, and here are the answers. First answer has given by Ashwin, proton, neutron, electron. Madhav, proton, electron, neutron. Lokesh, neutron. Rahul, 3 I need. Proton, electron, neutron, proton, electron, neutron. See, if you are writing only proton, if you are writing only nucleus, if you are writing only neutron, then it is not correct. Mahrunisa, Sharmila, Krisha, Lokesh, absolutely correct. The correct answer is electron, proton and neutron. So that is the most appropriate answer. Proton, neutron and electron is the correct answer. Okay, fine. Now write the names of 3 elementary particles which constitute an atom. The names of 3 elementary particles which constitute an atom are electron, proton and neutron. List 2 subatomic particles present in the nucleus. You know that. Which is the 2 subatomic particle present in the nucleus? Which is the 2 subatomic particle present in the nucleus? You know this answer here. So I am just waiting for your answer. We will be going for the next slot because I want some big answers. Yes, which is constituting the nucleus? Neutron and proton is constituting the nucleus. Absolutely correct. Today back to back you are giving all answers. Now next question, I am just going to go towards the next question. Let's see what is the next question. What are the limitations of Jj Thomson model of experiment? What are the limitations of Jj Thomson model of experiment? Limitations of Jj Thomson model of experiment. What are the limitations of Jj Thomson model of experiment? Limitations, Jj Thomson model of experiment. You itself think. And what are the drawbacks of Thomson model of atom? An atom. What are the drawbacks of Thomson model of atom? I really want you to answer. Think about it. I'm just covering the screen. I'm just moving. So what are the limitations of Jj Thomson? Just you have to tell about. Madhav, drawback of Rutherford model was electrons should be distributed equally, not near low 2 electrons. It will lose energy and it will fail to explain atom spectrum. 1 minute, Madhav. Here you have to rectify some of the parts. See, look here. Drawback of Thomson model of atom, positive sphere, electrons embedded in it. Yes, that was exactly the correct one in precise. See, look here. Only one small thing, Madhav, you have to change here. And that is drawback of Thomson model of atom was electrons should be distributed equally, not near 2 electrons. It will lose energy. It's not about that. It's exactly the last point of what you are telling now. So you have to just create a change in that one. You have to just say one very important point that exactly what Keshav has given the point that exactly what he has done. He has given one watermelon experiment. He said that the positive charges are distributed inside the structure wholly, and exactly the plum region or that region is negative charge and the structure is electrically neutral. So this was his concept. He said that like watermelon seeds are there, in the same way in rather than seeds we can say that the positive charges are there. Rather than seeds we can say that positive charges are present in presence of seeds, and whatever is the other regions are there in that is negatively charged. So the number of positive and negative charges are equal, so atoms are electrically neutral. So electrical neutrality concept was very nicely given by electrical neutrality concept. I am again saying it was very nicely given by Jj Thomson, that is number of proton equal to number of electron, but he did not talked about the structure. So he was basically lacking a very important structure. So since he was lacking the structure, he told that all the electrons are distributed on the structure, which was a major drawback. Why it was a major drawback? Why it is exactly not a because Jj Thomson experiment was followed by Rutherford experiment. When Rutherford did the same experiment trying to know that where and all are the locations of positive charge and how positive charges are exactly equally distributed based on Jj Thomson experiment, But he found another thing. He found that it is not exactly the number of positive charges present in the structure. It's exactly positive charges present at the nucleus, and it is concentrated at the nucleus. It is not present in anywhere around nucleus. Okay, and negatively charged particles are revolving around it. So this was the major finding of Rutherford experiment, which Rutherford has done to prove Jj Thomson's point, but he failed to prove Jj Thomson's point because he found that electrons are exactly revolving around the nucleus, and the proton is present inside the nucleus. That is, the positive charge of an atom is concentrated in the nucleus. That's why his concept, Jj Thomson concept, was not explained by some other scientist, or it was not followed by some other scientist, because there was a major drawback. I hope everyone might have understood this point. Come on, quickly tell me, did you understood this point? Electron embedded in the positive charge pair, the electrons and protons have same magnitude. Okay, that is, the number of positive charge equal to number of negative. He failed to explain the stability of atom. Correct only, but stability of atom he did not fail to explain. It was Rutherford who failed to explain the stability of atom. It was, I repeat my statement, it was Rutherford who failed to explain the stability of atom. Rutherford tried to explain the Jj Thomson model of atom, but he failed to explain the Jj Thomson model of atom because of a very important reason. That is, when he saw his experiment, he understood nice explanation, ma'am. Thank you, Madhav. He understood one thing, that according to the rays, he found that electrons are the positively charged particles which was embedded on the gold foil, it is exactly going back, and some of them are striking. The strike rate was like that it explained that no, something is present. It is not whole, because when positive charge will be Thank you so much, Madhav. So when positive charge will be present in the structure now, and it will be scattered, then its impact will be less. You have to understand one thing. I will give you sticks. Okay, so I'm not going to talk about sticks, but I'm going to give you some chocolates, and I'll tell you that distribute the chocolate. You will throw the chocolate everywhere. Then the density of the chocolate will become less, and people will find less interest to take that chocolate. But when you will keep the chocolate together, Darshani, are you hearing it? When you will keep the chocolate together, it will look in bulk, and that means what? That time the affection for the chocolate will increase. In a way, I am telling that if positive charges are distributed, then the impact of that positive charges will be less. But when positive charges will be concentrated, and that too concentrated in a small region, then it will be more impactful. It will have the repulsive force. Okay, so if any positive charge, see, accumulation of charge, positive charge is here. Now if any positive charge will try to come, it will experience a very strong repulsive force. Okay, that is what I am trying to say you. But if positive charges will be scattered everywhere, and some positive strong beam of light will be coming, then the scattered positive charge will not have that impact, according to Jj Thomson experiment and Rutherford experiment. That is the massive difference between Jj Thomson experiment and Rutherford experiment. Jj Thomson said that positive charges are exactly embedded like this, and negative charges are present nearby around the region, and number of positive charge equal to number of negative charge. So atoms are electrically neutral. Okay, so to prove Jj Thomson point, Rutherford did the experiment. So now when Rutherford did the experiment, what he found that most of the rays exactly went undeflected. Only few which went very near exactly made some angles, and out of 12,001 retraced its path. So that was the last point where we have understood one thing, that if protons might have been totally scattered on the structure now, then this case of deflection might have never came, because that will be having less impact, because these rays are very strong positive charges. Okay, so they are coming with a very high force, and their strike rate is high. So to fight with that strike rate, we need unity. Unity means a bulk of positive charges, and you know where is the bulk of positive charges present? The bulk of positive charges were concentrated in the nucleus. Because of that, a very fast moving alpha particle got deflected by making some angles when it tried to go very near to the nucleus. This is the only major explanations. I think I've already given this explanation. Everyone, come on, quickly tell me, did you understood? So limitation of Jj Thomson experiment and Rutherford experiment, I think I've discussed both of that. So can you repeat the drawback of Jj Thomson again, ma'am? Yes, the drawback of Jj Thomson again is exactly, beta, understand this. The Jj Thomson experiment did not explain about, see, he talked about neutrality. What is the meaning of neutrality? The meaning of neutrality is number of positive charge equal to number of negative charge. This is exactly called as neutrality case. So when in an atom the number of positive charge will be equal to number of negative charge, then the atom is said to be electrically neutral. But rather than that, what he has done is he was explaining about another point. He was explaining about another point, and that another point was ki Rutherford was explaining about Jj Thomson experiment, but none of the scientists backs Jj Thomson because they tried to do the experiment to know that Jj Thomson concept is correct, and you know what, they failed to understand that Jj Thomson experiment was absolutely correct or wrong, and this was the major drawback there. Are you understanding? So none of them supported, because once Rutherford experiment came into conclusion, it was crystal clear that because alpha, positively charged alpha particle, it is backing, so it has, see, if a very strong something will be there, then only it will fight back. Now something is coming with a very high force, to fight back with that you need a very strong support. So if nucleus is very strongly positively charged, then only it can withhold alpha particles, and it will allow alpha particle not to pass through it. Rather than that, it will repel the alpha particle by making certain angle, and this has exactly happened. So neutrality is number of proton is equal to number of neutron. Absolutely correct. Number of proton equal to number of electrons. Neutrality, number of electron is equal to number of proton, means number of positive charge will be equal to number of negative charge. I hope you might have understood this point. He did not tell about the experiment. Fine, he did not tell about the experiment. That's absolutely correct. Okay, so he was explaining, but his explanation was not enough. Shall we read what book has written? Because I think we discussed from all the corners of the answer. Let's see what book answer is. Although Thomson model explained well that atoms are electrically neutral, this is what I also said, but the result of experiment carried by other scientists could not explain by this method. 100% na, Jj Thomson model of atom was trying to be backed by others, but nobody was able to back it because it was not supporting the point, and the point was only one, that is the positive charges are scattered in the structure, then how it is exactly reflecting the rays? It is not possible. I hope you might have understood. So, and this is what Jj Thomson experiment is telling, that Thomson model proposed that consisting of Thomson sphere and the electrons are embedded in it, but Rutherford observation that electron revolve around the nucleus in well definite orbit, and that was the critical one to check it. Okay, so why we are going to follow the one which is not exactly applicable? Now go for question number 11 and say the answer. Absolutely right. Difference between electron and neutron with respect to charge and location. So this is the most easiest question, I guess. This is the most easiest question, I guess. What is the question is, write difference between electron and neutron with respect to charge and location. Where is Shrutika? I am missing her a lot today. Where is Shrutika, Sharmila, girl power today? Everyone is sleeping. Ashwarya, where are you all here? Where are you all? No answers coming from girl side. Only boys are rocking. Only Darshani and Kanishka, they are fighting back. But rest other all answers are coming from boys side. What happened to girl power today, huh? Yes, Shruti, I want you back. I want a fighter. I want a fighter. It's not like I want a fighter who can fight back and give the answers. Okay, you know what team I am waiting for. Madhav, electrons are negatively charged. Shrutika, electron negatively charged in the nucleus. Madhav, electrons are negatively charged particle. Neutrons have no charge. Okay, neutron will be located in the nucleus. Shruti, neutron no charge. Extra nuclear part. absolutely, that is extra nuclear part, electrons will be present. You have to be very precise, Shruti. So electrons negatively charged, electrons are negatively charged particle. Okay, fine. So I am taking your points. Exactly what is given here is which right difference between electrons and neutrons with respect to charge and location. So I'll just say that electrons are negatively charged, present in the extra nuclear part. Neutrons are neutral, having no charge, present inside the nucleus. See, I asked if you will ask my name, I will not say my full family name, I'll only say my name. Fine. So that is the most apt one. Na? So here also what you have written is absolutely precise and good. So don't write big things there, just write what they have asked. Next is name the subatomic particle not present in the hydrogen. So now which subatomic particle is not present in hydrogen? Come on, I want answer. I want this question answer. Name the subatomic particle which is not present in hydrogen atom. Let's see who can answer first. Shruti, welcome back, Shruti. The subatomic particle which is not present. Ashwin, electron and neutron. Come on. Madhav, neutron. Vishal, neutron. Krisha, neutron. Sharmila, neutron. Ashwin, neutron. Kanishka, neutron. Ekta, Ashwin. Keshav, good morning, Keshav. Keshav, hibernating or sleeping? Describe. Or playing right now. Rahul, Lokesh, where are you? Rahul has given the answer. Keshav, good morning. Come on, say hi to auntie. Say hi, auntie is waiting for you. Your reply. So let's see, you went for drinking water or went for taking snacks? Come on. Ashwin, no ma'am, I came to said about previous question. Yes, Ashwin, no problem. But I am exactly thinking about Keshav. Where is he? I know, Ashwin, you are giving answers today. Well done, well deserved answers you are giving. Fine, I am just waiting for one monster whose name is Keshav and he is not looking and I am unable to get him right now. Sharmila, good morning. Sharmila has already given answer. Fine. So let's see. Write the difference. So exactly the subatomic particle. We know that in hydrogen is exactly a special case. In that special case, we are seeing that, ma'am, I have been writing. Ayyo, Keshav, you will be getting this PDF. Okay, no need to write anything. You will get with answers. You don't worry about it. Fine. And then you will write this. All questions we will discuss. From top to bottom, all the questions before examinations, we are going to cover it up. Don't worry. Ma'am, he is here. Ashwin, I know that he is here. Okay, fine. So now let's see. So we have understood one thing, that neutron is only absent in hydrogen structure, and that is the place where it is located. Where is the place neutron is located? The place where neutron is located is nucleus. So nucleus is the place where neutron is located. Fine. So we have exactly seen the answer. Let's go back to the next question here. What is the next question? Yes, Lokesh, I want you to answer like anything. Write the answers very fast. Type answers. See, have competition between your friends, because it's last time we are revising the chapter wise content, and after this we will be having one examination. Fine. So now list 3 observations in alpha particle experiment which led Rutherford to make the following conclusion. Most of the space in an atom is empty. Whole mass of an atom is concentrated in its center and center is positively charged. What are the observations because of which Rutherford has given these conclusions? Say the observations because of that Rutherford has given this conclusion. Rutherford gave this conclusion not for simplicity, na? So Rutherford has given this conclusion because of some reason. Can you tell me? Come on, you can answer. Come on, you can answer. Okay, most of the rays passed through the gold foil because most of the space in the atom was empty. Super. Most of the alpha particle passed through the gold foil. Yes. Because of that, he came into the conclusion that most of the space in an atom is empty. Super. Go for the next one. Whole mass of an atom is concentrated in its center. What made him conclude this? Can you tell me? What made him conclude this whole mass of an atom is concentrated in its center? Ayyo, now I am having time for another class. So whole mass is exactly concentrated in the center. Can you tell me? Whole mass concentrated in the center. whole mass concentrated in the center. Can you tell me the answer? Whole mass concentrated in the center. Tomorrow morning again we are having class. I am lagging by one class. I have to capture that class again. Most of the alpha particle pass through the gold foil. Yes, absolutely. When come to center, okay, Keshav, come on, complete the statement. It's not a complete statement right now. Most of the space in an atom is empty. Whole mass of an atom is concentrated in its center. How he came to know? Madhav is telling because some alpha particle returned by making 180 degrees. Are they making 180 degrees? Okay, pass through means it is going to retrace their path. Absolutely correct. Darshini, ma'am, time please. Okay, fine. So, an atom consists of a positively charged particle, correct only, Ekta, because electron mass is negligible to the proton. That's one point is that electron charges are exactly negligible. But the next important point, what you have to exactly see here is that most of the, some of the rays which went very near to the nucleus, they got reflected back by making some angles. Yes, that's what, Vishal, they went very near to the nucleus and then they got deflected back by making certain angles, and out of 12,000 only one has been exactly retracing its path. So this was the 2 point of observation exactly. That was exactly again explained that whole mass of an atom is concentrated in its center. Center is positively charged. So why center is positively charged? One simple answer is center is positively charged because alpha particles were positively charged, and these alpha particles, when they went near, they got reflected back. Okay, so that means only positive. See, like charges repel each other and unlike charges attract each other. So here it was a case of repulsion rather than attraction. Okay, so they both repelled each other, and then only that out of 12,000 one went back because it got repelled. If it might have been negative charge, it might have got attracted. Then we could not have seen that rays because it is going to make the things neutral. But rather than making it neutral, what it did is it reflected it back and it made some angles and it is getting scattered in different directions. This was the conclusion. Until time, okay, fine, Srivatsan, that's it. Children, I hope you might have liked today's class. Tomorrow 100% morning class will be there. Today my health was in a very bad situation, so only I didn't keep the class. Now I'm feeling much better. You are seeing that I'm laughing, I'm teaching, so time up. Okay, yes, and that is positively charged. I hope you might have enjoyed today's class, children. So tomorrow morning we will have, yes, bye beta, tomorrow morning and evening both time we will be having class. Okay, bacha party, tomorrow morning and evening both time we will be having class. All the best everyone. Bye.